The last biogeochemical cycle we'll talk about is the hydrologic cycle, or the water cycle. Obviously, water is a key component to all living things. It's essential for life, for the movement of molecules, for various biochemical reactions. And so all living things need water. And so if we imagine the water on the earth, okay, we can see this, this infographic, this graph here, shows us sort of where that water is. If we think about all of the water on the earth, vast majority, 96.5%, is in the oceans. It's marine water. It's salt water. Okay? Fresh water is only 2.5% of all of the water on earth. If we further break down that fresh water, so of that 2.5%, we look in this middle column of all of the fresh water, 68%, 2/3, is locked up in glaciers and ice caps. Another 30% is groundwater, which is stored in the soil, in aquifers. And then surface waters, lakes, streams, rivers, etc., make up a little more than 1% of the fresh water on Earth. If we then take that surface water, that 1% of fresh water, and look at the breakdown of that, most of it is in the ground, frozen in what we call permafrost, 20% in lakes, and then smaller amounts in various other reservoirs of that fresh water. So when we think of water, we can think about 4 different reservoirs or pools of water. There's water in the atmosphere, there's water in the oceans, there's water in the ice, and then there's groundwater. Okay. Certainly there are other categories, other areas, but we're talking about sort of the majority of water. This is where you find it. And most of the flows of water from one of these pools to another is powered by the sun. One that you may not be familiar with is this process of transpiration. Transpiration is when plants take in water, typically through their roots in the soil, and then that water moves up through the vascular tissues of the plants. Eventually it evaporates, or it's released from the leaves of plants during various chemical processes, and returns that water vapor to the atmosphere. So that's called transpiration. Evaporation is when liquid water evaporates, changes into a gas, water vapor. That's typically driven by solar energy. Precipitation, movement of water from the atmosphere to where it's in the form of a gas, a vapor, to liquid water falling as rain or snow or any other type of precipitation. We have runoff, which is water flowing over the surface of land in streams and rivers and surface flow, and eventually most of that water makes its way back to the ocean. And finally, infiltration is when water falls on the land and is absorbed into the soil, into groundwater, or recharges an aquifer. That's infiltration of water. So here's a model of the hydrologic cycle, which shows you most of the things I just mentioned. So we have water in the atmosphere, we have surface waters, especially in the ocean. Okay, we have groundwater, which is what this is showing. This is sort of showing a cross section here. So we're looking into the earth, and we can see below surface level we have these areas where we can store water. This is groundwater. And groundwater can flow underground. Okay. The level where that groundwater is called the water table. So in some areas the water table is very high and close to the surface. In other parts of the earth it might be much deeper. So when we think about the fluxes and flows, we can see precipitation takes that water that's in the atmosphere, turns it into rain, snow, etc., where it precipitates onto land or into the ocean. We know that water can evaporate from the ocean, from surface waters into the atmosphere. Here we have transpiration, where the water makes its way through producers, vegetation, back into the atmosphere. Yeah. We also have the runoff when the precipitation falls on land. Some of that water can run off or move over the surface of the land. Some of it can percolate or infiltrate into the groundwater. And these are overall the flows and pools of water that we find on Earth. And we also know that as humans alter ecosystems, we alter the hydrologic cycle. Here are some examples of that. When humans remove vegetation, here we see a forest on a hillside that's been what we call clear cut. Basically, all of the trees have been removed. And when that happens, this leads to what's potentially much greater amounts of runoff. Typically, producers' plants, their roots can anchor the soil and they can hold on to it and they can absorb large amounts of water when it falls on the surface. But when we remove that vegetation, those roots no longer hold on to the soil, they no longer can take up the water, and so it leads to surface runoff. It leads to the waterlogging of soils, which can eventually lead to these mudslides as we see here. So clearing the vegetation reduces transpiration, increases runoff and erosion. Paving areas, taking an area that's a field, a forest, even if it's a man-made field or forest or park, changing that from that ecosystem to pavement, asphalt, like a parking lot or a road, or building houses. That does is it reduces the amount of infiltration of water into the soil, because those asphalt, roofs, etc., concrete are impermeable. The water can't go through it, and therefore it increases runoff and can increase erosion. Here we also see what humans often do is diverting waters. This is a dam that was built on a river, and what happens is the dam holds back the water, altering the hydrology of the area, the movement of water. It takes a running body of water, such as a river, and changes it into a reservoir behind the dam. It also has significant effects downstream of the dam. It reduces sediment that is being that's used to help decrease shoreline erosion. We'll talk more about that as we move forward.